Now we are going to see open versus closed fractures. We are going to see open versus closed fractures. So we start with closed fractures. We need to know that when you are going to see closed fractures, in closed fractures, you need to point out that you have already give the definition that the bone hematoma is going to is not going to communicate with the surrounding environment with a closed fracture. Inside closed fracture, you need to know that there are certain fractures, examples of fracture that can occur in closed fracture. Is it clear? We have cases like when you have you have different fractures occurring here. The first fracture that you can have a fracture which is a transverse fracture in closed fracture. You can have the second one, which is a spiral fracture in closed fracture. You can have oblique fracture in closed fracture. Basically, I'm going to draw each of these of them when I'm going to show you the AO classification. So I'm not going to draw you that now. Now, the fourth fracture in AO class in the closed fracture, we are going to have also a segmental fracture in the closed fracture. The fifth fracture in closed fracture, after the segmental fracture, we have wedge fracture. Is it clear? We have comminuted fracture. Comminuted fracture is one that has more than one fragment. So when it has two and more fragments, it is said to be comminuted fracture. Is it clear? Now, apart from fractures where there is a typical break on the bone, we have other fractures associated now with compressions. Is it clear? So they are compressional fractures, and these fractures which are associated with compressions are in sites where there is a high compression of the body. It's taking high weight, and particularly the spine is involved there. So in the spine is involved with compressional fractures. So this one I'm going to draw the diagram because you're not going to see that in AO. It is only seen when you visualize a spine fracture in the case of a Dennis classification. Is it clear? All the specific classification, I'm just going to send it through. I'm just going to send the specific classification of Dennis through, or the specific classification of all the fracture through the commentary part. Is it clear? So on compressional fracture, this is how it resembles. So you have one vertebra as such. Are you seeing? You have the intervertebral space. You have another vertebra as such with the spine. The intervertebral space, you have another one with this spine. Now you see that if you have now another bone that is making like this, it is bulging outward like that. So when it is just compressed, the first element is that that bone needs to be compressed. After the intervertebral space, you have the bone outside, which is compressed. Is it clear? If the bone is compressed, meaning that the size of that bone has reduced, it is now going to be called a compressional fracture. Now the second element is when you have the spine and the vertebral body, the spine, intervertebral space. Let's say that here now you have now the reduction, a bulging outward. You have a reduction in size here, and then it's going to bulge outward. Is it clear? So you have a reduction in size of the vertebra, and then it bulge outward. That reduction in size and the bulging outward is now called another fracture type called the wedge fracture, still associated with compressions. Is it clear? And lastly, you can have this vertebral body and the spine and the intervertebral space. Now it reduces in size, and after bulging out like this, it breaks. There is a break now like this. We produce a fracture, a visible fracture line posteriorly. With the wedge and the compressional fractures, they are not actually fractures, they are compressions, but they are considered as fracture, though there is no particularly break in the bone. The one that has a typical break in the bone is the one which is now having this third part here, where there's a reduction in size of the vertebral body and there's a break posteriorly. This one is called now the burst fracture. So those are the fractures associated with the closed fractures. Now, the next fracture associated with closed fracture, we have avulsion fractures. Avulsion fractures are other fractures associated with closed fractures. Now, here after having seen examples of fractures in closed fractures, we're going to see now the major classification of closed fracture. The major classification of closed fractures. closed fractures. Now, we need to know that we have major classification of closed fractures and we have specific classification of closed fractures. The specific classification of fractures of the spine is going to be Dennis classification. The specific classification of the fracture of the femoral neck is going to be the Gardner's classification. Specific classification of the fracture of the femoral head is the Pipkin classification. But all those are going to be based now in order for you to have a decision making based on the management of the patient. But this one, the AO classification, is just the general classification of all closed fractures. So the general classification of all closed fractures is AO classification. And then what does AO is also called the Mueller classification. Basically, Mueller classification. Now, for the people who insist to know what is the meaning of AO, AO is actually a German name which means Arbeit, Gemeinschaft, für Osteosynthesefragen. Osteosynthesefragen. So that is the full meaning of AO. If you really want to know AO, this is it. Albert Gemeinschaft für Osteosynthesefragen classification. So now, what is the AO made up of? The AO is made up of 4 elements. You are going to have 4 elements in different of their boxes. Basically, the first element represents the bone which is involved. The first element is the bone which is involved. The second element represents the site of that bone, the site of the bone. The third element, after the site of the bone, it represents now the after the site of the bone, you are going to have the next point, which is if it contains fracture fragments. Is it clear? If you contain fracture fragments or not. And then the fourth element, after containing fracture fragments or not, you have the next part, the one which is associated with that. Is it clear? So this fourth element depends on the fracture fragment part. Is it clear? So these ones are numbers. This is a number, this is a number, this is a letter, and this is a number. Is it clear? Now let us explain these two, and then these other two here are working in pairs. I'm going to explain that in pairs. Is it clear? Now we need to let's first understand the first part, which is the bone. Is it clear? Let's first understand the first part, which is the bone. Now you need to know that when the bone is the humerus, here the number which is given here is number 1. I hope you understand it. When the bone is if the bone is the ulnar or the radius, if you have the ulnar or the radius fracture, if the fracture of the ulnar or the fracture of the radius, here is going to be number 2, or even the fracture of both, it is still number 2. So you are going to have the fracture of the ulnar, you consider the fracture of the ulnar, and then the fracture of the radius, you consider the fracture of the radius. Now the next one is the site. If you are having the different element, let's say that this is your bone here like this. This is the bone here like this. When you are having fracture at the level of the proximal third, it is number 1. If you have fracture of the proximal 1/3, basically it is number 1. If you have fracture of the middle 1/3, it is number 2. And if you have fracture of the distal 1/3, it is number 3. Is it clear? Now generally you need to know that these two parts here are the epiphysis and the metaphysis with the fascial plate. Is it clear? So they are generally called the epiphysis, while the middle part is called the diaphysis. So when they say a fracture of the diaphysis, you have to understand that it already involves the middle 1/3. Are you understanding? So those are the different elements. Now the next point now, which are the letters. I told you that the letters are going to be in adjunction with the next number. Is it clear? Now A, B, and C are the 3 letters. A corresponds to fracture line. When there is a fracture line without any fractured fragment. Is it clear? When there is a fracture line without any fracture fragment, it is A. If you have a fracture line without any fracture found, it is A. Now B, if you have a fracture with